All right, let's get started. Welcome and good afternoon. Thanks everyone for joining us here to do a deep dive into EC2 T2 instances. My name is Luke Hoban. I work on the EC2 team in AWS. And with me is Scott Burks from Pearson, the world's largest education company. And together we're going to spend the next hour or so talking about T2 instances. We're going to talk about the what, the why, and the how of T2 instances. And we're going to give that perspective both from the product perspective and also from the perspective of a customer who's using T2 instances heavily for cost savings and to get really good performance out of those instances. So what will we cover today? Few things. First, I'll take a look at sort of the core EC2 instance families and the core portfolio of EC2 instances we offer, and take a look at how T2 instances fit within the rest of the EC2 portfolio. We'll take a look at the T2 credit model, which is really the one unique characteristic of T2 instances that is worthwhile to understand to really make sure you can use T2 instances most effectively in your applications. We'll hear from Pearson, from Scott, about how they're using T2 instances, what their migration was like, how they understood where to use T2 instances and where not to use T2 instances. And we'll also hear a little bit about some of the guidance they use internally for when T2 instances are the right fit for them. We'll take a look at a few workloads which can be really good fits for T2 instances. And finally, a few tips for when you do start using T2s, things to pay attention to and to think about for those needs. So to get started, I wanted to sort of give some of the background on T2s. So we introduced the T family into EC2 in 2010 with the introduction of the T1 Micro. And the T1 Micro introduced this notion of bursting, which was giving really good performance, but for applications which didn't need to use the CPU all of the time. So if your application was one that used the CPU occasionally or irregularly, T1 Micros could give you a really good experience at a lower price. We expanded this in 2014 when we introduced the T2 Micro, T2 Small, and T2 Medium. And T2 really did three things. One, it was a significantly higher performance offering than T1. Two, it was cheaper than T1. And three, it offered these three sizes, so you could fit more types of workloads into the instance. We followed that up. These T2 instances, after we launched them, were one of the fastest growing families we saw, and so we saw a lot of demand for expanding the product line. So last year, we introduced the T2 Nano at the small end with 512 megs of RAM, and the T2 Large at the top end with 8 gigabytes of RAM. One other notable thing about the T family has been that this has been the instance that's available in the free tier for EC2. So T instances tend to be one of the first things that many customers new to EC2 use for the first time. And so that means that a lot of customers have some usage of these, but some of the details are not as familiar. Just yesterday, we actually announced two new sizes in the T2 family, the T2 Extra Large and the 2X Large. And these were actually based on, as we saw the usage of T2 instances across our fleet, we saw that there were a lot of customers using the largest sizes, the medium and large T2s. And they were using these for the cost savings they offered for the applications which didn't need to use the CPU all that heavily. And we were getting a lot of asks for expanding that up to even larger sizes for workloads which needed that additional memory, the 16 gigabytes and 32 gigabytes of RAM that these offer. And so this is something that we're going to sort of continue to look at, is expanding this line of burstable instances to address more and more scenarios going forward. So before we get into the details of T2, I did want to sort of take a look at how T2 fits with the rest of the EC2 families. So most folks are probably familiar with our core sort of compute offerings, our C family, our M family, our R4, which we actually just made available yesterday, is the newest one in that family, and the X1, which we introduced earlier this year. And these core compute offerings, you'll see sort of each one has a different kind of ratio of compute to memory. And the combination of all three gives a lot of options both on how big overall you want your instance to be and how you want to balance the availability of memory, CPU, and networking. And so together, these sort of expand all the way from very compute-intensive workloads, like batch compute jobs, all the way up to very memory-intensive workloads, like large in-memory databases. So this is the core offerings. Now, I should also note that both of these are sort of logarithmic axes. So this actually covers a very wide spectrum of sizes here. But I'm trying to fit it on a simple chart like this. So we've got logarithmic axes. So how does T2 fit into this? So T2 instances, you can see sort of accomplish two things as they relate to the rest of the EC2 instance family. The first is that they give you the option of some smaller sizes. So if you have an application which needs a smaller amount of total compute and you want to still package that as an EC2 instance, we now have offerings at the half a gig, 1 gig, and 2 gig sizes in the T2 family. The larger sizes actually play a different role. They give you a lower cost way of doing things which there were alternate instances. In the case of the T2 medium, that's similar to a C4 large in terms of the core specifications of the instance. And in terms of the T2 large, X large, and 2X large, those are going to be similar to the equivalent M4 instances in terms of the specs. But again, they're going to give you that burstable instance at a lower cost. And so really those are the two sort of core things to think about in terms of how a T2 instance might fit within your applications. So that kind of gets to the core of how I like to think about T2 instances generally. T2 instances can offer a really great performance at a low price for workloads which do not need to use the CPU all of the time. Now the really key thing to this is that it turns out the far majority of instances that run in EC2 actually don't use the CPU all that heavily. There certainly are some applications which are really maxing out their CPU, but most applications do not. And so there's actually quite a lot of applications which are really good candidates for the cost savings that T2 offers. And we'll take a look at some examples of that in a second. But really, this is the sort of key thing I want you to keep in mind as we talk through the rest of the details here. All right, so I mentioned its great performance. So let's get into a little more detail about what that means. So how many people here knew that a T2 instance burst performance was higher than a C4 instance? Raise your hand. Okay, a couple. Yeah, so I think this is one of the things that surprises a lot of people about the T2 instances. Is I think because of the T1 micro and things like that and experience people had in the past, it's often thought that maybe T2 instances are less performant than some of the other instances in EC2. And it actually turns out that T2 instances offer really good performance while they're in that burst mode. So some of the best performance that you can get in EC2 is actually what you get with a T2 while it's in burst mode. And so these two graphs show how a T2 medium and a C4 large compare. And you see sort of two things. One is that the T2 medium is about 40% higher effective performance while it's bursting. And then after it's, if you run out of burst credits, then its performance does go down beneath that. Similarly, for a T2 large compared with an M4 large, there's an even bigger gap. There it's about a 60% higher performance. But the gap at the baseline level is a little bit less, as you can see there. So really the key takeaway here is as long as you don't run out of credits, you're going to get really great performance. And so as we look through all the examples of where T2s fit really well, they make the most sense when your application fits within that amount of credits that it gets given, so that it can burst all the time that it needs to use the CPU. The question there was, are those both supposed to be T2 medium? They're actually not. A T2 medium and a C4 large are very similar specifications, and a T2 large and an M4 large are actually very similar specifications. So these are sort of the instances that are most comparable here. Similar charts to the one on the right would apply for the T2X large and 2X large as well. Okay, so let's look at a few of the examples of where this can kind of make sense and the kind of workloads that are really going to fit within this well. So the first one is sort of occasional bursts with a low average. And so one of the examples I like to talk about here is sort of continuous integration servers and build servers and that sort of thing. And we've seen a lot of usage of T2s in these kinds of workloads. And so this is sort of, I made up this particular graph here, but it's sort of suggestive of this kind of workload where it's very bursty, the short bursts as we're doing a build or whatever is coming along in the build server. And there's lots of these bursts, but they're kind of spread out a bit. So the server is not running workloads nonstop. And so here you might have something where your average over 24 hours of CPU utilization, based on this data here, is about 5%. So it's not that much, not using the CPU all that heavily. But you are really taking advantage of the fact that when you are using the CPU, when that build is running, you're getting really good performance. So you're delivering that build back to the developer as quickly as possible. And so this combination of while you need the CPU, you need really fast CPU and a lot of horsepower, but you don't need it all the time is sort of the key thing that you're sort of seeing here. And so this can be a good fit for really any size of T2, from a T2 Nano all the way up to a T2 2X large, really depending on how much memory you kind of need to run those build jobs on your build server. A second example, which is sort of qualitatively a bit different, is this example of longer bursts but less often. And so for this, you might be talking about sort of a virtual desktop application or a line of business application within an enterprise. And in this case, you can sort of see the business hours there, right, where the application has a period of the day where it's getting a lot more usage. And then outside of that period of the day, the usage is much reduced. In this sort of example, you might have the case that during the business hours, the usage is actually somewhat high. In a virtual desktop example, that user may be spending a lot of time, editing Excel documents or whatever, and they're actually using a little bit of CPU during that period of the day. But again, because there's these long periods of the day where it's not getting used, the average, again, is quite low. In this case, maybe about 10%. And so I think in this case, there's sort of two examples here. For the line of business applications, those are things which often can be sort of compressed down into small size instances, like a 1 gigabyte T2 micro. And that T2 micro can be used to sort of run each of those line of business applications, which don't have that heavy of demand on the CPU, but can be delivered in these small sizes. For virtual desktops, your users may need more memory, and so again, you're going to scale up to meet the sort of memory demands of your customers in that scenario. So of course, there's going to be applications which aren't a good fit for T2, and it is important to recognize that as well. In this example, maybe we have a video transcoding worker job, and this is something where we're going to maintain very high CPU utilization almost all the time. And so here, your average utilization over 24 hours is about 80%. And this is the kind of thing where you're going to want to go and use an instance like a C4 that really can have full-time high performance. The good news, of course, is EC2 offers lots of instances that give you that kind of performance. And so for those applications which need this kind of performance, that's what you should use. Okay, so that's a quick overview of some of the sort of where you might think about using T2 instances. Now, I've talked so far really about these average utilization. We talked about sort of the 5% and 10% and 80% average over 24 hours. But let's get a little bit into the details of kind of what the model is underneath that and how it enables you to make sure that an application which only uses the CPU about 10% on average will be able to get burst all the time. So a T2 instance has this notion of credits. And a T2 instance gets CPU credits. And each credit provides the performance of one CPU core. And this is actually important that it offers a full CPU core, not a hyperthread, which is what most EC2 instances offer. It offers a full CPU core for 1 minute. So every credit that you see will be 1 minute worth of using a CPU at 100%. So an instance earns CPU credits at a constant rate. And so every different size earns a different number of credits per minute. And so as long as that instance is turned on, it's going to be earning credits. And then it can consume credits whenever it wants to burst and use the CPU. So whenever you try and use some CPU, that will use up some of your credits. And then credits expire every 24 hours. So the credits you earned 24 hours ago, we expire 24 hours later. And this is what really makes sure that that sliding window is going to average over the last 24 hours of your utilization. And so really the net result of all of this is kind of what I was talking about in the previous examples, which is that at the high level, you really just have to think about, is my average utilization over a trailing 24-hour window higher or lower than the amount of burst capacity I get with a T2 instance? And so for sort of the gory details of that, this is what we have in the documentation for T2 instances. Each size, you'll see, gets an initial number of CPU credits. And so this means that when you start up a T2 instance, even before you've earned any credits from running the instance, we want to make sure you have enough to do all the setup tasks you want to do on that instance. And one thing you'll notice is that every one of these instance sizes offers 30 minutes of running at full CPU utilization of all of the cores. So the first 3 there each have 1 core, second 2 have 2 cores, and then X large and 2X large have 4 and 8 cores respectively. And so that means that no matter what T2 instance you run, you can run it full out at 100% CPU utilization for 30 minutes before you'll even start using up the credits that you're earning. So CPU credits earned per hour, this is sort of how fast you're going to earn those credits. And so, for instance, for a T2 medium, you're going to earn 24 minutes worth of running at full performance every hour. And so what that turns into is the number you see in the third column, which is the base performance. So this is 24 divided by 60 is 40%. So that's the base utilization that you're able to use a T2 medium for. Now, the important thing to notice is that this is of a single CPU core. So a T2 medium has 2 cores, so you can use one 40% of the time, or you can use 2 20% of the time. And either one of those is going to count the same in how a T2 does that accounting. The other sort of last important thing to notice here is the maximum earned CPU credit balance. And so this is like how much, over that 24 hours of time, how much can you accrue so that if you have a really intense burst of CPU needs, you can sort of build up a lot of capacity and credits and then use it. As I mentioned, this is the 24-hour period. And so each of these is going to be how much can I accrue over 24 hours so that then I can start spending it later in that day. So all of this is really just the details. It's not super important to pay attention to all the specifics here. It's useful to know this model, though, when you look at how we expose some of this data through CloudWatch metrics. So the CloudWatch metrics that we expose for T2s, we offer 2 additional CloudWatch metrics that are unique to T2 instances. There's the CPU credit balance and the CPU credit usage. And these 2 metrics give you visibility into how those credits that you're earning and spending are counting for each one of your instances. They also give you the ability to create alarms and things like that to understand when you're potentially at risk of running out of credits, or to look at some of your applications and make sure that, that they're getting that burst capacity as much of the time as they need to. And finally, of course, as CloudWatch metrics, you can hook these up to other automation. For instance, using these to scale automatically as your credit balance gets low. So with that, one of the things I wanted to do was quickly show you a demo of some of that in action inside the console to give you a sense for what that feels like. Could we switch over to the laptop? Great. OK. So here I have a T2 medium instance. And T2 mediums, as I mentioned earlier, are one of our more popular sizes of T2 instances. And so this T2 medium I have running in the Ohio region. And let's go over and look at the monitoring tab. So I'll show you, this is an instance that I started this morning. And I immediately ran a very compute-intensive workload on this. And so you'll see when I started the workload there, it immediately popped up to almost 100% CPU as I ran a very heavy CPU workload on this. And then over a period of time here, its performance sort of slowed down until it got to about 20% here. And I mentioned that's the baseline. Once you kind of run out of credits, you're going to get down to that 20% baseline performance. And then I stopped running the workload. So we weren't using the CPU at all after that. So that's what you would get from the normal CPU utilization CloudWatch metric. But let's take a look at what that looks like in terms of CPU credit balance. So this is during that same period of time. You'll notice I started at 60 CPU credits. So that's that 30 minutes of running full out that I get with a T2 instance. And then I slowly went down over that 30 minutes until I got down to near zero. And as I got down to near zero, this is where you saw that performance being reduced back down to that 20% stage. When I stopped running this task, I started earning credits again. And so this has just started going up. And this will go up again until I get to about 24 hours. And it'll hit a peak, and it'll sort of flatten out once I've accrued all the credits I can on this instance, as long as I don't use any of them. And so this sort of gives you, this is not what you'd actually be doing with any real instance, but it gives you a sense of kind of what those curves look like and how the CPU utilization is related to the CPU credits. The other interesting thing to show here is that I've added an alarm, which is at this 10 CPU credit balance level. And so these alarms are a way that I can make sure that if I'm ever getting low on credits, I actually get notified about that. So I can go and understand how often is that happening. Is this an application which I need to consider moving to a larger size or to a non-T2 instance? And so we can actually go and show you sort of some of how we can do that. So we can come and create an alarm. And we can do that either, there's sort of two things that make sense here. One is to alarm on CPU utilization becoming maybe greater than 50, or in this case, maybe greater than 20% over the last 6 hours. And so maybe I want to know, is my CPU utilization high over periods of time that will be unexpected? Or similarly, I can actually go and create alarms on those unique metrics to T2s, like the CPU credit balance. And so I can say if my credit balance goes below 10, and 10 is going to mean for my 2 cores, I can run for 5 minutes if I'm running at 100%. So I'll make sure that if that happens for a 5-minute period, that I'm going to create that alarm. So the CloudWatch alarms here and the CloudWatch metrics that are exposed give you a lot of visibility into this system. So we want to make sure that you have all the tools to understand how to use these things effectively and when they're not fitting your workload perfectly. Can we switch back to the slides? All right. So with that deep dive into kind of some of the mechanics of T2s, I wanted to hand it over to Scott to talk a little bit about how Pearson has been using T2s and how they migrated some of their workloads and got some of the cost savings that we'll talk about a bit later. Thanks.
Great. Thanks, Luke. So as Luke said, my name is Scott Burks. I'm a senior application engineer at Pearson. Mostly what we do is help troubleshoot, monitor, even deploy out instances for the teams and help the teams with that into AWS. I assist in all that and even suggest right sizing of the instances if the team needs. So Pearson started building into the Amazon EC2 in 2012. Currently, we have about 120 development teams. These are in the US and in Sri Lanka. Of that, there's 470 applications. Most of these are development applications on Linux instances, run in Java, APIs. And then we have some that are legacy applications that we've kind of force-fitted into the cloud where we could. As you can believe, this can lead to a large and growing AWS footprint. So here's some of our numbers. As you can see, the large numbers of instances. We've got a large number of elastic load balancers, a lot of storage, along with a lot of DNS records in Route 53. As you can imagine, this leads our accounting department to go a little crazy and watch our budgeted spend very closely. So how do we minimize the spend the best we could? Because of the nature of our teams, and when we started doing the AWS build, a lot of these were in the M1 families, kind of your generic type of instance, good for everything, good memory, good CPU. Sometimes this was oversized for the application and underutilized. This produced obviously some spends that were unnecessary because of the overutilization. So with all of our applications, we're still writing obviously, and with traffic increasing on our current applications, how can we grow and increase our number of instances while being fiscally responsible? So what we did was we did a migration to T2s. we thought, what about these T2s? About the time we started looking at all this, the T2s were ramping up, being used by other teams. We started investigating and evaluating the T2 types. Try to minimize the spend, but yet still have the performance and reliability that we would with the other instance types. Obviously, these needed to be instances where the application could show a low average CPU utilization, and you had demands on the network occasionally for bursts on the CPU and the network during high traffic times. At Pearson, we have what we call back to school time periods. We've got students taking tests, students reading books, you got professors putting coursework out there, real high utilization time, especially on some of the applications. So what we looked at here were a lot of the T2 micros, T2 smalls, T2 mediums, T2 larges. We thought, hey, these, as Luke had said, these are great fits if you have low CPU utilization. But you also wanted to be able to burst higher than that utilization if need be. So a lot of these turned out to be mediums and smalls, as you can see. But you see that because you get a lot of the development teams doing all their development, their testing. Because of that, they're hitting a lot of those burst rates. So these were a real good fit there. And again, when we have the back to school time, when we have high utilization, the burst rate's really good. So as you can see from the numbers, these T2s added up to just under 1,200 instance types that got migrated. This turns out to be about 19% of our total number of instances at Pearson. So that's a pretty significant number. And it came along with a significant savings of about 11 to 20 grand a month. Now this makes our accountants obviously happier. So how did we get there? So May through July of 2015, we pushed all our teams to evaluate their applications and what instances they were using. In a lot of cases, M1s. And forced them to migrate off of the M1s. Some teams could do this easily, some not so much. The two factors that would affect the migration, the use of ephemeral storage could affect this. The M1s, obviously you have the ephemeral storage with the T2s. You're strictly left with just EPS storage. So if they needed the ephemeral storage, that migration couldn't happen. The other factor was CPU utilization. As Luke said, your sweet spot's about 5%. So if you have an average of 5%, this would be a good candidate for a migration to T2. But if the application demanded higher average rates, then T2s wouldn't be the right one. So recognizing all these cost savings, migrating off the M1s, we had a large number of them. These were our recommendations back to the teams. If you had M1 smalls, you go to the T2 smalls. M1 mediums, you would go to the T2 mediums, or if you needed the high CPU or the ephemeral storage, you could use an M3 medium. Obviously cheaper than our M1s. M1 larges, obviously T2 large, or an M3 large if you needed the CPU and the storage. And then at the time that we did the migration, there wasn't any T2 extra larges, so we suggested just go into the M3 extra larges. So here's our numbers. As you can see here, even though our footprint is always continually changing, particularly with development and staging and extra applications getting deployed, you can see that there's a significant increase in the usage of T2s. And then, of course, we have a decrease in the number of the M1s that we had out there. Some of these numbers don't add up completely just because there were a lot of teams that went to other instance types. We have a lot of Cassandra databases. They demand a lot of CPU. They couldn't be good candidates for T2s. Our results were, as you can see, an estimated savings of $9,000 to $15,000 a month after we had finished all this up. This was also a great cleanup exercise for the teams. They had to evaluate the needs. They had to evaluate what kind of instances had you put your application into. Was I underutilizing that instance? Was the instance too big for my application? And then, of course, as you can see here, the micros, smalls, and the mediums have increased steadily after migration even. So, use cases. We had a couple use cases where T2s were really big. One of them was our proxies, our HA and web proxy. The way we have our applications set up, we have elastic load balancers, and then we have proxies behind. These proxies behind served as yet another security and another load balancing feature, but it also offloaded our SSL. Sometimes that offloading of the SSL can demand a little more CPU, but again, you're talking about bursts, so this would be a great fit for a T2. With the numbers that you see there, again, you have a lot of numbers in development staging, again, because they're doing testing, they're doing development. You're going to get a lot more usage out of the T2 because of the burstable features there. Again, why does it work well with the proxies? Low CPU requirements. Proxies, all it's doing is going to be load balancing, maybe offloading an SSL. You also have good networking per dollar. So the spending would be low. You get great networking out of that. So our guidance to the teams here, these are the sizes and the guidance that we gave them. Network constrained instances being our proxies. As you can see with the T2 instances as compared to C4 instances, the number of cores, the amount of network, and then of course the price point, which as you can notice is very, very economical. Now, with the proxies, we had some trouble getting numbers. Amazon doesn't give any kind of numbers on these, so basically we had to use iPerf and create our own evaluation, set up our own numbers. Here you got the graph showing T2s along with M3s and C4 instances. I can think that you might imagine which ones are the T2s? Well, with the bursting feature, it's kind of easy to stand out there that top line there is all the T2s that we have and that we tested with. But even though the bursting nature here for the networking wasn't a critical component for our tests and our instance there, it also proved to be another great Pearson use case for workloads that need great networking, throughput, but are at an intermediate basis in other parts of the company. Our other scenario here are application instances. We have a lot of front-end application servers, whether they be an application server or just a plain web server. Again, the numbers show same kind of trend, a lot of development, a lot of staging, again, because of the testing, the development, performance, testing and such. Why do they work well at the application layer? So again, development staging, you're always going to have either a low CPU load unless they're doing their testing. So the credits accumulate for those surges during that testing. It's also a good memory per dollar for the Java. So high memory to CPU usage is a great fit for these C2s. Again, here's the guidance we gave our teams. for memory constrained, going from the T2 micro, small, medium, large, and then compared them to R3 larges and extra larges. Again, as long as the instance has a low CPU utilization by average, these are great fits for the application. Because of these findings, the guidance recommendations came straight from Amazon. We didn't have to do any further testing. And this provides a low spend per gigabit way to scale down instances for the application sizes smaller than 15 gigs, such as your R3 largest. So in summary, T2 instances grew from absolutely none, 0% in the company, all the way to 19% of our total instance counts over an 18-month period. The estimated savings for the company by migrating to the T2s was $11,000 to $20,000 per month on average. Right sizing guidance for the T2 instances, it also supports a lot of other workloads, including the load balancers and our app tier. And with that, I'll hand it back over to Luke.
Great. All right, thanks a lot, Scott. So I think there's a couple of things that Scott mentioned there that I think are really interesting to kind of call out. One is the networking that he mentioned. I don't know if you caught in that chart that as well as CPU bursting, T2 instances also give you some amount of network bursting. And so that means that for workloads which need to, infrequently get a lot of network bandwidth, you can actually get very good bursting network performance from a T2 instance. And this isn't something that all instances needed in the use cases that Scott mentioned. They didn't need that too much, but it is another interesting thing to think about. And I also like the sort of guidance that they had in those two examples for those two workloads. Is really interesting because it shows sort of both of those patterns, both how the smaller T2 sizes can fill out the sort of menu for a lot of different workloads for how you can, if you can bring things down to smaller sizes, you can fit them into instances. But also how the sort of dollar per gigabyte or dollar per networking can be a really attractive thing with some of these T2 instances. So in this last section, I just wanted to talk about a few kind of tips, things to think about. So the first tip here is some of the workloads that can be really good fits for T2 instances. So one that we know is very popular with T2 is the sort of websites and web apps. And this scales sort of across quite a broad variety of different kind of use cases. We have tons of sort of that long tail of EC2 users who have their WordPress blog or something like that running on a T2 instance. These blogs and other sort of simple websites tend to be very low CPU utilization, even for reasonably well-trafficked blogs. And so these are things that can run very easily on top of a T2 instance. So we have a long tail of those. But then even within sort of websites for startups or for inside an enterprise environment, we see a lot of sort of web applications being run inside T2 instances because of the generally low CPU utilization. Scott mentioned development and test a couple of times. This is one that's also a very common pattern we see. Development and test has sort of a few characteristics that are notable for T2s. One is that it's a very bursty kind of workload generally. It's not something that's seeing your production traffic hitting it all the time. It tends to be something where your utilization of those servers is more sporadic. And so it's something where T2s can be a good fit. Scott talked a lot about proxies and load balancers. Virtual desktops is another one. This is one where sort of the end user it's very hard for someone in the virtual desktop scenario to actually use a lot of CPU unless they're doing very specific tasks. And so it tends to be a good fit for these. When you look at virtual desktops run on premises, they're often run in environments with a lot of oversubscription of the resources, partly because of these same reasons. Continuous integration we talked about, and enterprise line of business. And of course, there's things that aren't going to be a great fit. You've got a batch compute scenario, you've got an in-memory database. These are generally not going to be things where a T2 makes sense. So we've talked a lot about kind of the performance, some of the scenarios that make sense, but it's also interesting to think about some of the reasons why and the directions where people come to T2 instances. And so these are a few that I've seen and talked to customers about. And it's interesting to kind of look at each one of these and how, why T2 makes sense in each one of these cases. So the first one we talked about a bit, C4, sort of M4 large to a T2 large. Here you get, you know, a bit of a cost benefit. It's about 13% right now. In fact, for those who aren't aware, we just dropped prices effective today on both M4s and T2s by 10% and higher in some regions. But because we dropped prices on both of these, that 13% still applies. But as well as being cheaper, as we talked about, this instance gets higher burst performance. So you actually get better performance at a lower price as long as you don't use the CPU all the time. The second one, which have actually seen me even more popular than that, and is one of the reasons why I mentioned T2 mediums are quite popular, is C4 large to T2 medium. And when I say C4 large here, that could be a C3 or, you know, any previous generation as well. But in this case, you get an even bigger price benefit. You know, in this case, it's about 50% lower price, so very significant cost savings there. And you get more memory. You don't get as many, well, in this case, you do actually get the same number of vCPUs. But again, if your workload doesn't use the CPU all the time, this can be a really significant cost savings. It's a couple other examples about sort of M3 mediums and C1 mediums. Again, these provide significantly lower prices. And of course, T1 micros to T2 micros, if you are still using T1 micros, there really is very little reason at this point to start up a new application running on T1 micros. T2 micros are purely better instances at this point in time, significantly better performance, significantly lower price. And so we definitely encourage users who have been using T1 micros in the past to consider moving to T2 micros. And of course, as of yesterday, with the launch of the T2 extra large and 2 extra large, we now offer sort of a path where that similar thing to the M4 large applies for some of these larger sizes as well. And there's that option to get that lower price and better burst performance. The one last tip I wanted to kind of talk about here is about launch credits. And this is one that, you know, it's documented in the website, but it's something that I've noticed in talking with many customers using T2s. Many folks aren't as familiar with. And it's more of a little detail, but it's something to keep in mind just in case it impacts you. So I mentioned that every T2 instance you start gets 30 minutes of credits when it starts. But this is only true for 100 instances per 24 hours for any given account. And this limit is one that we have in place to make sure that people don't abuse T2 instances and those launch credits that we offer. Because we give you 30 minutes of credits, we don't want people spinning up an instance and then shutting it down immediately and spinning up a new one and shutting it down immediately and really trying to take advantage of those launch credits to use that instead of having a low average CPU utilization. And so we have this in place mostly just as a sort of kind of almost a fraud protection measure. But it's a limit that we're very happy to increase. If you go and make a request to increase this limit, we'll just make sure that your usage is not really abusing the T2 model. And if not, then we'll go ahead and increase that limit. So this is a limit to if you have the kind of application where you're spinning up lots of these instances, but you are doing, you know, a substantial amount of work. And so, for instance, we've seen this impact customers who are doing things like CI/CD, where every time a build comes through, they go and spin up a new instance to do the build or to do a test run in a test environment. If you are starting up more than 100 instances per 24 hours in your account, this is something to watch out for. I'd make another case here. I talked a little bit about the CloudWatch metrics and CloudWatch alarms. This is another great one where if you do put those CloudWatch alarms in place, this is something where you'll get that information and make sure that you know that you're hitting these kind of limits and can go and put in that request for the instance limit increase. Okay, so that just wanted to sort of summarize some of the things we talked about. The first one is T2 instances really can offer great performance at a low cost for workloads which do not need to use CPU all the time. I think you've heard me say that several times. That's really the most important thing to take away from this session and when you think about how T2s could fit into your environment. I showed you how the CloudWatch metrics can be used to understand the CPU utilization. This is a really important tool. I think this is one of those places where we really wanted to give you the visibility into the underlying system so that you can make the right decisions based on that data. And we've seen from across a wide variety of workloads and from individuals running with their WordPress blogs all the way up to large enterprises running their line of business applications. T2 fits into many different workloads. And really this notion of low CPU utilization is something which isn't about being a low performance product. It's really about something that many workloads and applications satisfy. And so I encourage you to really think about when the applications that you're developing, how many of those really could be things which are candidates for a T2. And so with that, I'll actually open it up if anyone has any questions. I think there's a mic over on this side and a mic over on this side. We're happy to take a couple of questions, and Scott can take any as well if you have them. And if not, we will also be here for a few minutes afterwards to take questions in person. So with that, thank you.